Syzygy, episode 64, Almost a Good Comet. And welcome back for another edition of the Syzygy podcast, Isolation Edition, sitting on the other side of the country from me, but I can see her through my computer screen. Emily Brunston, how you doing, Emily?
Hello, hello. Yes, I'm doing just fine.
You're managing to stay sane, given, as he waves his arms about in the usual fashion, given all this?
Yeah, and I think, weirdly enough, the British weather is actually helping for a change.
I know. Like, what's that about? If it was typical weather of grey and cold and rainy, it would be pretty horrible. But right now, looking out my window, it's beautiful and sunny and warm, almost too warm at times. It's very strange. Very strange. You managing to get out and about for your duly allocated one exercise session a day?
Yes, and taking a nice stroll through the suburbs and then sometimes out to the river. It's really rather nice.
Excellent. Very nice. Very nice. But the listeners don't want to hear about us in our COVID-19 isolation trials and tribulations. What they want to hear about is astronomy and the cosmos. And today we're going to be talking about something which we haven't actually talked about before, I think, in the previous 63 episodes of this podcast. I don't think we've ever talked about a comet, have we?
No, I don't think we have. So this is very exciting.
So today we are going to be talking about a comet. Emily, what comet are we going to be talking about and why?
So this is Comet Atlas, which has hit the news kind of over the last month or so quite hard because it's a comet that was discovered, and we find a handful of these things pretty much every year. But this one was special because when we did the calculations to try and figure out, how bright is this comet going to be? Are we going to be able to see it in the night sky without a telescope? Then actually it looked like it might do something really rather remarkable and become one of these very special naked eye sky objects that we could see.
So just backing up on that a little bit, we do get a lot of comets. There are a lot of comets out there, but the ones that we can actually see with the naked eye and that are spectacular in the night sky, they're few and far between.
Yeah, exactly. So I think the last one that we've really had was Comet McNaught back in 2007.
Was that a particularly spectacular one, or was it if you look over here and really know what you're looking for, you can kind of make out that there's a comety thing?
It was a really good one. I'm actually surprised you might not have seen Comet McNaught when it came round. So it was a Southern Hemisphere comet. It was pretty much the brightest comet we've had in about 50 years.
I might have, but 2007's a long time ago, Emily. Like I'm flat out remembering what I did this morning, let alone sort of 12 years ago, 13 years ago. But yes, do tell me a bit more about Comet McNaught.
Yeah, well, I've got a few comets we can talk about, but if we start off with Atlas, then it might be kind of the next big comet. And we call these comets great comets. The great comet of 2020 would be what Atlas would be called if it did indeed become this great visible naked eye object.
Great comets. What makes a comet a great comet? Is a great comet just simply one that you can see, or what?
Yeah, so they're ones that you can see with the naked eye, that people can go out and have a look at, that they're bright and that astronomers will track, and amateurs will track across the sky over a period of at least several months usually.
Right, okay. And so a not great comet is one which we've seen, it's there, it's definitely there. It's just not great enough that we can see it with the naked eye and point to it in the night sky. That's the idea.
Yeah.
Right, okay, cool.
So Comet Atlas was discovered. It's actually got a proper name. So Atlas we name comets often after the discoverer, right? So things like Comet Atlas was discovered by what we're going to talk about, this Atlas telescope system. But usually it's after a person, because in the past most comets have been discovered by people. So our example for Comet McNaught was discovered by McNaught. But the problem with that is that McNaught's actually discovered like 50 comets or something like that.
After a while, that becomes a very difficult naming system.
Yeah, so there is a proper naming system, and I got really into this system. So this Comet Atlas is actually called C/2019Y4.
In the usual astronomical way of naming things in really prosaic ways, which is why we go for Comet Atlas, I guess.
Yeah. So, well, I got quite interested in this and went and thought, well, let's break all this down and sort of find out what these bits are. So we'll talk about what all that bits mean. But so C2019Y4 Atlas. So Atlas stands for the Asteroid Terrestrial Last Alert System.
So that's the telescope.
Yeah, it's actually a robotic survey, which is kind of an early warning system
Oh,
for
cool.
asteroids, comets, other bits of junk in the solar system which might
So
be headed our way.
this is the system or part of the system which is going to go, guys, don't want to alarm you or anything, but see that big chunk of rock that's coming our way? Yeah, that's a problem. You might want to do something about that. Or at least, take cover. It's one of them.
Yeah, so I guess a little bit of the clue in the name there too is that it's the last alert system.
Yes. Basically, there's nothing you can do, but at least you've been warned. I've done my job,
Yeah. So it is looking for things that might have been missed by other kind of surveys and observations, particularly very small things, because very small things are very hard to spot. These asteroids and comets, unless they're, in a special, very, very close to the sun and not actually particularly bright. So they're quite hard to spot. So they estimate that asteroids may be kind of on the size of roughly 20 meters or so, which is kind of similar to the size of the Chelyabinsk meteor, which came in and broke up in 2013 and caused a bit of damage and that sort of stuff. So they reckon that those sorts of objects would be found maybe a few days up to a couple of weeks before impact.
Right. Not necessarily much you can do about it at that point, but it's nice to know. But it's I don't know. I guess I take some heart in the fact that if we are going to hear something from these people at Atlas, it's not, by the way, we're all going to die. It's, hey, check out this comet, which is nice.
Yeah.
That's a much better
outcome. And at least,
outcome.
I guess, if you did have a week or so's notice, you can evacuate the local area that might be affected by such an object.
Depending on how big the object is, yes.
Yeah, so this Atlas, so it's actually a survey system made up of currently 2 telescopes. It's run by NASA and the University of Hawaii. They've got 2 half-meter telescopes, so they're not super huge. But what's pretty impressive about them is that these 2 telescopes sit in different islands in Hawaii. And between them, each of them surveys a quarter of the entire sky 4 times over the course of a night.
4 times a night?
Yeah, so do you take a quarter of the sky, which is a huge area, right? That's a big bit of sky. And it will look at that 4 times in an entire night, each part of that quarter 4 times. And it's looking for things that change, right? Those observations.
So you've got to know where all the stuff is that isn't changing, and then look for the tiny, minute, incredibly dim little changes that suggest that there's something there.
Yeah.
That's a lot of data.
So between them, if you have 2 clear nights in a row, then you've covered the entire visible sky from Hawaii, which is pretty impressive.
That is very impressive. But it also makes sense then that it's actually really quite a good tool for spotting things that aren't going to come and wipe out a large chunk of humanity and the rest of life on the planet, but is actually much more exciting and lovely, like a comet. It's good for that.
So it might be worth, at this point, I guess, checking and saying, well, what is the difference between kind of this asteroid, the comet, the meteor? These are all sort of words of different things.
Yeah, and it's easy to use those interchangeably. And I always have to stop and think really hard. Hang on, am I talking about a meteor or a meteorite or an asteroid or just a chunk of rock or what? So, let's figure out those words. Where do we start?
Yeah, so what Atlas is really hunting for are asteroids. So these are kind of chunks of rock that were left over from the formation of the solar system. And they're flinging out around in the solar system. And many of them are nicely confined to the asteroid belt, which is between Mars and Jupiter.
Yep.
But you can get disruptions in that belt. You can get things that are kind of catapulted around. So there might be things that are sort of whizzing around on other orbits in the solar system.
Okay, so you find a lot of asteroids in the appropriately named asteroid belt, but they're elsewhere as well. There's chunks of rock just flying around all over the place. And I mean, Earth gets hit by chunks of rock all the time. Mostly very small ones, but this is happening all the time, right?
Yeah, and so that's when you start to call then the meteors and meteorites.
Okay, so what's a meteor?
So a meteor is when you've got this blazing thing that's streaking across the sky. So what's happening is that bit of rock is kind of burning up in the Earth's atmosphere.
Okay, so asteroid, chunk of rock, meteor, chunk of rock that hits the Earth.
Yep.
Yeah, okay.
And then meteorite is chunk of rock that makes it to the surface of the Earth.
Right.
Not all of them
so
do.
the ite bit, which I mean, you get ite on the end of all sorts of different kinds of rocks and minerals and so on. And so meteorite is chunk of rock that's actually made it to the surface of the Earth, and it's sitting there in perhaps a smoking crater, but it's there. It's made it to the surface and hasn't burnt up completely on the way down.
That's right.
Okay, cool.
Yeah.
So
because lots of things that are very small, like if you got things that like the particulates, a piece of like a grain of sand, then that's just going to burn up in the atmosphere and be completely gone.
Yeah. So, okay, that's asteroid, meteorite, comet.
Yeah, so comets are kind of the odd one out, I guess, in this kind of little group because they're not made of the same kinds of stuff. So comets are, I think, the most famous sort of way to think about them as a dirty snowball.
Right.
So they're chunks of rock and ice which have come from the very, very outer parts of our solar system. We've talked about kind of the scale of the solar system before, and the very sort of furthest bit, if you like, this cloud that sort of enshrouds the entire solar system very, very far away, is the Oort cloud. And the Oort cloud's really cold, there's not much sunlight gets there.
It's a very long way away, yeah.
Yeah. So all your things which we call volatiles like nitrogen and oxygen and so on, they all freeze into ices. So you get these icy snowball things which are kind of dirty because they're polluted with bits of rock and dust and so on from the solar system.
So when you talk about ice, you're not necessarily talking about water ice that we would refer to it down here. You're talking about things like frozen oxygen, nitrogen, that kind of thing as well.
Yeah, but there is water in comets as well.
Yeah, but it's not just the water ice that you're talking about. Cool.
Yeah, there's lots of bits and pieces.
Okay, so you got this dirty snowball which has formed way, way out in the outer reaches of what we define as the solar system. But then it gets closer to the sun. What happens?
Yeah, so something changes at this object's orbit. It means that it comes in on a very eccentric orbit. So it's coming in close, very, very close to the sun. And when these comets come in close to the sun, they heat up. They're getting more energy from the sun. And they start to basically vaporize, become that extra heating. So particularly the nitrogen, the carbon monoxide, and the carbon dioxide are the three sort of critical species. And they start to vaporize. And this forms a tail behind the comet, which is very, very bright.
So the snowball, which is formed of things which, I mean, they do freeze in the cold depths of space, but you need to be pretty cold to have, frozen solid versions of these gases. And as soon as it starts to warm up, they unfreeze, and you get this long tail behind. How, when does that tail start to actually happen? How close does it have to get before it's warm enough for that to actually happen?
Yeah, so it starts, probably from about the orbit of Jupiter, but then to get it into being really visible, then you really want this comet to be coming in between Mercury and the Sun.
Right.
That's when it's going to be really bright.
But the tail's definitely there, even as far away as Jupiter.
Yeah. Well, they get this kind of halo around the entire, this lump, around the nucleus of the lump of rock. And what's really interesting is that comets actually have two tails.
Two tails. Okay, explain that.
Okay, so when you're thinking about your comet that's coming towards the sun, it's got a tail which is pointing away from the sun because the sun's warming up one side of it and it's pushing off all the gases so that they're moving away from the sun.
Okay, sure, makes sense.
Right. It's also got a tail which is the stuff that's actually coming off as the bits sort of come off the comet that's left behind. That is where the comet used to be.
Oh, I see. Right. So this comet is winging its way down through the solar system, coming towards the sun, but it's not going in the exact direction of the sun. It's going in an orbit around it. It's coming down closer, but it's not moving right down towards the sun. And so you've got the stuff which is left behind in its path of its orbit, but then you've got stuff being pushed out directly away from the sun, which is at a different angle. So you've got two tails.
So when it's coming into the sun, those two tails pretty much line up, right?
Yeah.
But when it gets quite close and it starts to go around, let's say it goes around the other side of the sun from where it was originally coming in from, then you're going to have the tail pointing away from the sun, but the tail of debris, which is actually just stuff coming off the comet, which is following round on its orbit. So it's going to be 90 degrees to that. Yeah,
so it's sort of going sideways. Can you see both of those tails? Like when one which is really, really clear to the naked eye, could you see both?
We can't see them with our eyes, but you can with if you look in different wavelengths.
Right, okay.
Because you can start to see different components that are coming off the comets.
Which one are you seeing then with the naked eye? You're seeing the one which is coming from away from the sun, right?
Yeah. That's the brightest tail.
Right.
Yeah, the other one's much, much fainter.
Right.
But the other one is interesting, the tail of kind of the stuff coming off that's being left in the wake. That's the one that causes our meteor showers.
Ah, okay. So as these comets are winging around, they're leaving behind a whole trail of stuff, and the Earth can pass through that trail, and we see that in the night sky as lots of shooting stars. That's what you're saying.
Yeah. So that's quite
Awesome.
cool. Yeah. Anyway, so this particular comet, so if we come back to its name, 2019, the 2019 is kind of maybe obvious part of its name.
I think we can figure that one out. It was discovered last year.
It was discovered last year, yeah. So it was actually discovered in December, really right towards the end of December last year. And at the time, it was really, really faint. So Atlas managed to pick it up, but it was at a magnitude of what we call 19.6, which is super faint.
Yes, if I remember correctly, magnitude, the bigger the number, the fainter it is.
Yeah.
And 19 is quite a big number for magnitude.
It's very, very big. So it's much, much fainter than anything you can see with your eyes in the sky. So you can see things on a really dark, clear night down to maybe 6 magnitude.
Right.
And so this is
19 is a very long way away from 6.
Yeah, and it's not just linear. So every 2.5 steps in magnitude, that's 100 times fainter.
Oh, good Lord. Okay, so this is very, very, very dim. I'm quite impressed by the people at Atlas. Well done. How far away was it when they saw it?
So it was, I haven't got the full distance, but it was kind of similar distance to the orbit of Jupiter, but probably a bit further then.
Right.
So then, between December and its discovery and March, so they started tracking this object and saying, well, this is interesting. There's a little comet coming in. It increased in brightness 27,500 times.
Wow. Okay, that's a lot.
Yeah, that's really a lot. Yeah. So this got people quite excited because you've got this comet coming in and it's getting brighter really, really quickly and becoming quite bright. So on the 1st of this month, the 1st of April, it was actually 7th magnitude.
So that's almost visible on a nice dark night.
Almost visible. You could see it with binoculars if you knew where to look.
Wow. And it's still got quite a long way to come in to get into the sun.
So its brightness peak, if you like, is predicted to be kind of end of April, early May. Mm-hmm. But and following those original predictions, it was going to be as bright as Venus in the sky.
Wow, that is pretty bright when you consider that Venus is, the morning star, the evening star. It's the first thing you see when it gets dark, when the sun goes down, if it's in a good position. That's really bright.
Really bright. And it was going to be very green as well.
Very green. Why green?
So this particular comet's got lots of diatomic carbon, which is molecular carbon. So it's 2 carbon atoms kind of stuck together. And this is a very green compound.
Awesome. Okay. Now, you were sort of talking past tense there. Have these predictions been revised? Is it going to be that bright or not?
So, unfortunately,
is this the disappointing part of the story, Emily?
Yeah, I know. I'm gonna shatter this comet, and I'm gonna shatter your hopes as well.
Oh, no.
So, sometime around the April the 9th or the 10th, this comet shattered and kind of fell apart.
I guess that's a hazard with comets, isn't it?
Yeah, so this happens quite regularly with them because what happens is you've got lots of gases which can be trapped in kind of small pockets, and those gases get heated and expand, and it can sort of blow apart the comet itself.
Oh, that's such a shame.
Yeah.
So we were on track for this big, green, bright, comety thing, and then it just went and blew itself apart.
Yeah, so it's now in at least 3 or 4 different bits. We can still track it and see it with telescopes. And we can actually see these different bits, which is quite interesting. So one fragment is about 34,000 kilometers in front of the other pair, or other 3. So it's kind of really spilling out. And what that means is that because it's all spreading out, all these little different bits, is that the brightness that it would have had is all spreading out, so it makes the whole object a lot fainter.
Right. So are there any predictions at the moment that any of it's going to be visible, or is it just that hope's well and truly dashed?
It's not going to be visible with the naked eye, is our current prediction. In fact, It looks like it's now getting fainter. From the latest measurements I've seen, it's gone over its peak in brightness, and it's now going to start getting fainter and fainter.
Oh, it's such a shame.
Yeah, it is.
I mean, I know that it wasn't malicious. I know the comet didn't do it on purpose, but that would have been a nice thing to be able to wander out. I mean, you were talking about end of April, early May. Like, that's just a couple of weeks ago. Well, weeks away.
Yeah. So it would have been very exciting to see these things, but no, well, it's not this one. But there is some interesting stuff about this comet that I think we can delve into a little bit deeper. Mm-hmm. So one of the interesting things that we found out is that this comet passes very close to the sun, well within the orbit of Mercury. In fact, much, much closer to the sun than Mercury. So it's actually on an orbit that's very similar to another comet that we have seen before.
Yeah.
Which was called the Great Comet of 1844.
Sounds very impressive.
So this
Does it have another name?
I didn't check that.
Or is that just what it's... Do astronomers actually literally refer to it as, yes, well, of course, you'll remember the Great Comet of
1844.
You remember the Great Comet of 1844. Whatever happened to the comets we had before the war, eh? They were better in the old days.
Yeah, well, we can talk about the names of... I've got the names of some of the more famous ones that you might have heard of, in case you haven't heard of the Great Comet of 1844. But this is a comet that... Maybe if it's the same orbit, then it's kind of on a maybe 6,000 year period orbit. Mm-hmm. So it returns every 6,000 years.
That's a very long orbit.
It's a very long orbit, but we do expect these things to be quite long because the Oort cloud is generally really far away.
But when you think of it, like one of the most famous comets of all time that people know about is Halley's Comet, right? And that's on an 87-year cycle?
75, 76, yeah.
75, I thought it was in the 80s. So that's a long time. And you get a sense of comets of, well, they don't come back for sort of 50 to 100 years. No, you're talking thousands. Thousands of years.
Yeah. As most of them are in these thousands of year kind of cycles.
Right. So it's actually the things like Halley's Comet which are the exception. That they're actually fairly rare. Oh,
yeah. So this Great Comet of 1844 was nearly first magnitude, which is kind of as bright as some of the stars in Orion.
Wow. Okay.
It was visible from the southern hemisphere. Now, in 1844, there weren't a lot of European people in the southern hemisphere, shall we say?
Not a lot. There were some, but not a lot.
But there were enough, and it was visible kind of actually from near equatorial regions and even up into the UK as well. So I managed to, this is where I went a little bit down a rabbit hole and got quite excited. I found a paper.
You've had fun, haven't you?
I found a paper from the Astronomical Journal. Now, the Astronomical Journal is one of our big journals of astronomy. You know, it's one of the big places you publish all your exciting new research. This is edition number 15.
So very early.
Very early edition in 1850. And this paper was called On the Great Comet of 1844. Okay. It's written by a guy called Bond, and he talks... It's actually remarkably easy to read, given it's a paper from 1850, 160, 70 years ago.
Well, I mean, I'm guessing the sort of scientific and mathematical machinery of astronomy was somewhat more basic back then.
It was, but what I really loved about this paper is that it's an example of international collaboration in science.
In the mid-19th century.
Yeah.
Okay.
So in this paper, there are 138 observations of the comet, which is already not bad, really, considering they did have pretty primitive equipment. 85 of them were taken from the Cape of Good Hope. 25 were taken from a place called, which I had to look up, Trivanadium, which is in India. Mm-hmm. 13 from Naples. 15 from Greenwich, Cambridge, Regent's Park, Berlin, Attena, which is in Hamburg, and just all over the place. These observations were taken,
that is really impressive.
Yeah, it's like international collaboration in science, which you think is kind of a very modern concept.
Yeah, well, particularly when they didn't even have email or Slack or anything like that. It's not like you could just ping someone a message and say, quick, point your telescopes up here. Like, that took coordination in those days.
So these people are posting their observations and letters around the world, which is really exciting. I thought that was quite cute anyway.
Yeah, nice one.
Yes, but then coming back, I think, to these comets, so they made some observations and, found out that this Great Comet of 1844, they calculated its orbit, etc. So this Comet Atlas was on a very similar orbit. In fact, it might even be a chunk off this other comet.
Really?
That fell
off
off
the Great Comet of 1844?
Yeah, so it could be a smaller chunk that fell off it at some point and it's now come around.
Wow, that's cool.
Yeah, so that's interesting. So, right, let's talk about some famous comets and some of their names, because I also went down this rabbit hole as well, because I got quite excited about this.
Because as you've said, I mean, we I don't know, I always thought that comets were named after the human being that discovered them, because, as I said, the most famous of the famous ones is Halley's Comet, and that was discovered by Mr. Doctor, Professor, her Doctor, Fraulein Doctor. I have no idea who Haley was, but I assume that Haley was a human being.
Yeah, yeah. So that is true, but these people, as we say, discover hundreds sometimes of comets. They spend their lives working on these things. So you can't just call, Comet Haley 1, 2.
Haley 1, Haley 2. Well, you could. I mean, Emily, let's be honest.
Could.
Numbering things is what astronomy does well.
But what we want to do is, make a really interesting system that we can work with. That's what we like to do.
Oh, I see. Right. It's not just the numbering. Astronomers want the system. Got it.
So this particular naming convention's come about since 1994. So we sorted it out then.
Good.
Now,
Excellent.
let's have a look at our Comet Atlas, which is C2019Y4. C/2019.
So hang on, I can make a start on this.
Yep.
C stands for comet.
No.
Oh, damn it! I've fallen out of the gate. Gate.
Yeah. That would make sense. The C.
Yes, it would. It would, Emily. It would make sense.
The letter C is actually designating what type of orbit this object is on.
Okay. All right.
So we have P for periodic. So that means it comes around.
I was about to say to you, tell me that the orbits go A, B, C, but that would be far, far too obvious. And astronomers would start it at B anyway, even if that was a system. But sorry, okay,
yeah.
I digress. There's P, there's
P
C,
for periodic.
there's what?
Yep. So that means
P
it comes around again and again.
Yep.
C for not periodic. Don't ask me why.
Of course.
It might have been a comet thing. I don't know.
Who knows?
And the other name, well, there's a few more, but the other one I think which is relevant to us is D, which is disappeared or broken up.
Gone, which could be the case here.
Yeah, so we might have to rename this one D 2019.
Put a line through the C and make. So hang on, I thought. I mean, other than the ones that break up and disappear, other than the Ds, I thought all comets were P. I thought that was part of sort of the whole cometiness of comets, that they're on these long eccentric elliptical orbits and they come back.
Well, actually, most comets are on what we call hyperbolic orbits.
Okay.
Which are things that come in really close on these crazy eccentric paths, but then they go back out into the Oort cloud and they interact with something, or they just sort of calm down, and then they lose that eccentricity.
Right. So it's not a closed ellipse. It's we wing our way in towards the sun and we wing back out again. We might keep going or we might just sort of stay out there, but you don't come back.
Yeah.
It's not periodic.
That's right. Yeah.
Okay.
So most comets are actually the Cs.
Right.
Yeah, okay. So then we got 2019, Year of Discovery. So
that one we know.
Yep, that's good.
Easy.
The next one, we've got a letter and a number. So the letter corresponds to the half month in which the comet was discovered.
Half month. Okay, so first half, second half of a month.
So we start with January A, January B, February C, February D, etc., etc.
Right. Okay. Yep. That's a system that I can get on board with. That makes sense.
And then the last number is the number which is which number discovery was it in that month? So was it the first, second, third, fourth, 10th, 15th, etc.
Did they go with half months for a particular reason? Why couldn't they just do January, February, March, April?
I'm guessing there were just too many.
Are there that many comets that they would have run out of numbers?
Yeah, we do find quite a lot of these things. So I haven't seen many of them go above 10 yet for a half month. So maybe they were trying to keep the numbers down.
Fair enough. All right. It's sounding a little bit like the license plate system here in the UK, that you can look at a license plate and tell when the car was made. It's a similar kind of thing. Did they get their inspiration from UK license plates?
It does, and it sounds really rather logical, and then it's going to make a lot of sense, and then everything's going to be sorted out, and it's done. Yeah. Until you sort of get to the point where you realise that some of these comets get mixed up with asteroids, and then they get asteroid names, and it gets a bit messy after that. But we'll leave that one go.
I can see the astronomical community just going, it's good, it's sorted, we're done, we've got a system, we're done now. And then the reality hits home of, but applying the system is the hard part. How do you know what you're looking at?
Well, if we look at a couple of our famous comets that we've had over the last, shall we say, 30, 40 years.
Sure.
So we had Comet McNaught, as we say, in 2007. Comet McNaught is called C/2006 P1.
Okay, so P, hang on. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O. P, so that's the 16th letter of the alphabet. So that's the 8th month. So that's the second half of August.
Well done.
Hey, I can count and work things out in my head.
Excellent. Yeah, so that was when it was discovered. So it was discovered in 2006, and obviously it got a lot brighter, and then it was visible to the naked eye in January, February 2007.
Yep.
So this is the brightest comet that we've had in the last 50 years or so. I remember it. I did actually go and have a look at it.
I'm trying to think. What was I doing? So hang on. When was it at its brightest in 2007?
January, February
what time? January, February. I'd like to think that I was out there gazing up at the skies, Emily. I'm going to say that I was.
Yeah, I was a student at university at the time. I'd gone home for our summer holidays at that point. So I remember we walked down to the local estuary, sort of over the water. You had to kind of go and look at it at twilight because it was so close to the sun that the sun sort of washed it out. So just after sunset, we went out and had a look, and you saw this huge thing. It was utterly enormous. I couldn't believe how big it was.
Wow.
This big streak of a comet tail across the sky. It looked like it was coming up out of the estuary, up in the water. It was really amazing.
Wow, that's so cool. That's so cool. Okay, yes, I'm definitely going to say that I definitely saw that, yes.
So McNaught's not going to be returning to us.
That's right, because it was a C orbit.
Yeah. So, it's not been upgraded to a P, so it's probably it's probably back out in the Oort cloud, or heading back out to the Oort cloud. It's probably not going to come back. It's going to sort of hang out there. The other one, which many people actually saw, was Comet Hale-Bopp.
Yes. Now that was a really interesting one.
Yeah, so this was 1997. Mm-hmm. But Comet Hale-Bopp has the designation C/1995-01. So it's again one of these. At least we don't know yet if it's going to come back. There's some predictions that maybe it's on something like a 4,200 year orbit, but at this point we don't know. So it's still a C. It's discovered in 1995, and that's really relevant because Hale-Bopp was the longest visible naked eye comet that we have on record.
Wow. Longest as in over a period of weeks and months. Is that what you mean?
Yeah,
or going back through history?
So Hale-Bopp was visible to the naked eye for 18 months.
Oh, I see. Right. Wow.
Yeah.
That's a really long time.
Amazing, isn't it? So it was mostly easiest to see in the Northern Hemisphere, Hale-Bopp. Mm-hmm. And in fact, it was brightest in April 1997, which really massive coincidence. I happened to be on a family holiday to the US. And I remember staring out the car window and thinking, what is that giant big blob in the sky?
What is that thing? Oh my God, says proto-astronomer Emily.
Yeah. So I got to observe Hale-Bopp as well. It's really quite exciting.
Awesome. But did you see Halley's Comet in the 1980s?
Well, this is where it gets a little tricky. So Halley's Comet, which has got two names because it's a special one.
Yes.
So it is called 1P Halley. So it's called 1P because it's the first periodic comet that was ever discovered.
Ah, right. And I mean, we've got records, because it's on a 70-something year cycle, we've got records of Halley's Comet going back a really long time, haven't we?
Yeah, the earliest one I found was 240 BC.
Yeah.
Recording.
Yeah, which is nuts.
Crazy,
That's nuts.
yeah.
But I mean, humans are pretty good at spotting patterns. And when you see this weird thing in the sky coming back every 70 to 80 years, you tend to notice that and you tend to write it down.
So the last time that Halley's Comet came to us, it got its designation 1P 1982 UI.
Yep. So 1982, so U towards the end of the year. I'm not even going to do the counting. And yeah, okay. 1982.
But of course, Halley's
it was
Comet
the early 80s.
wasn't actually visible to the naked eye in 1982. It was visible in February 1986.
So that's when it's gone back around the other side of the sun?
Yeah, and become a bright object that you can see.
Right, gone out the other side. Now, I do remember that, because I could remember as a teenager in the 1980s, a very long time ago. Yeah, that's enough from you. Thanks, Emily.
I was alive, if that helps.
That there was all over the news was Halley's Comet, it's coming, it's going to be amazing. And then it was a little, if I'm honest, a little bit of a disappointment, because for a while it was sort of supposed to be fairly high up in the sky and everyone's looking forward to it. And if you squinted, you could kind of make out a bit of a smudge. And I think most of the non-astronomical world kind of went, well, that's a bit rubbish. And I was amongst them as a teenager. But I happened to be on a bus heading out into far-flung distant regions of inland Australia, going to visit a friend on his sheep station. on a sheep farm, and it was a really early morning, just as the sun was coming up, kind of affair, a bit like you when you saw your comet coming up out of the estuary. And I looked out of the window and I tried to wipe a smudge off the window next to my head, and it wasn't a smudge, it was Halley's Comet. And it was really, really cool. But it was at a time of the year when no one had sort of flagged, hey, it was going to be really visible this time of year. It's great. And there it was, down really close to the horizon. It was fabulous.
Fantastic.
So I did get to see it in the end.
Yeah, I cannot confirm or deny whether I've seen it or not.
How old were you at that point?
Just over a year.
Yeah, probably not then. I mean, you might have seen it. You just may not have really appreciated it.
Not so much. So, well, of course, Halley's Comet being the most famous comet, it does return every 75, 76 years-ish. So February 1986 was when we last had it. The next one is due in 2061, 2062.
So that's a little bit of a wait. We got a bit of time.
Yeah, so this is the only comet which you can see with your naked eye twice in your lifetime. Well, you have the possibility of, at least.
Yep, depending on when your life starts and ends, you know, how close you are to that particular cycle. But yes, there's a very good chance that a lot of people will see it twice.
Yes,
Yeah.
so that's exciting. But in some ways, it's not a very good comet, and that it doesn't go anywhere near the Oort cloud.
Can you split comets into good and not good comets?
Well, I looked up this, and it's like Halley's Comet only just goes beyond the orbit of Neptune and then comes back again.
Right. So what's going on there? I mean, did it presumably come from the Oort cloud and then just got kind of bumped off course and is now in this particular orbit?
It seems likely that something's just got to sort of bent it into a much shorter period orbit than it normally would have had.
Yeah.
Yeah. So, it's kind of, again, the most famous comet is maybe not the best kind of typical example.
It's not the best example of a comet. But I mean, for it to come back every 70-something years, it's got to be in a relatively small orbit. If it did go out all the way out to the Oort cloud, we wouldn't see it every 70-something years. That's how that works.
So if you're looking out for the next kind of big, spectacular, beautiful comet,
yep,
Halley's Comet's really not going to be that, because it's fairly mundane. It's been around the sun a few times. It's lost a bit of its stuff. It's only going to get fainter and fainter slowly over time.
Yeah.
What you do want, and this is my kind of next section, or final section, if you like, is what makes a good comet, and how do we get a good comet? That's what's
you just said a minute ago Halley's Comet's not a particularly good comet. So go on. Okay.
So you want a very, really good comet to be a new comet, to be the first time that it comes in from the Oort cloud. And that means that it's as big as it possibly can be. It's got the most volatiles that it can have.
Hasn't had any of the stuff blown off it yet.
Yeah. And so it's got lots of nitrogen. Again, what we said, this carbon monoxide, carbon dioxide, all this lots of lovely stuff that's going to vaporize and form this big, bright trail. And so you're going to want this thing to be on the parabolic orbit the first time it's come into the solar system, which means that it's unpredictable.
So are you about to tell me that that's not something that you can tell us when we're going to be able to see it?
No, and that's why things like Atlas do come in. We only discovered it in December, and up until literally 2 weeks ago, we thought, oh, this is going to be amazing. This is going to be one of the best comets we've ever seen. And then
because you just don't see them coming.
Yeah, so that's only in a few months. So whilst this Atlas comet is not going to be the next great comet of 2020, there's still time.
It could happen. It could happen. So how often? I mean, I guess if you look back through the examples you've given, it seems to be roughly once a decade we've been having pretty impressive, or in this case, almost really impressive comets coming through. Is that about the right kind of frequency that we'd expect?
That's an interesting question. I'm not 100% sure. I mean, it does sound like it from the last sort of 30, 40 years that's about right. Yes, well, let's hope so. Let's hope we get another one soon.
And with any luck, it'll actually manage to hold itself together this time. Well, that brings us to the end of this comet-tastic episode of the Syzygy podcast. Listen, Emily, if people want to get in touch with us to badger you about, so when is the next time that we're going to get a viewing of a great comet, or even just to throw us a question or a hint at a story like Circus Stew did for this one. He's the one who threw this one our way, so thanks, Circus Stew. How can people get in touch with us? What can they do?
Well, all the internet's still going.
So all the internet.
We are on all the internet.
God for that.
All the ones that matter, anyway.
I think 2020 should be the year of the internet, frankly. If we weren't happy for it before, we certainly are now.
So we are at SyzygyPod, SYZYGYPOD.
We are. Where can people find us on the internet in particular?
So we are on Twitter, we are on Facebook, we have a beautiful website, syzygy.fm, and Instagram, which is a thing that's still on my phone that I'm figuring out how to use.
Emily, you should be you've got the perfect opportunity right now. You've got all of this, going on, and you're stuck at home. I think you should get stuck into the SyzygyPod Instagram account. That's your challenge. Challenge for the week.
I was just going to brush up on my Python, but
No, look, you can do that in your own time. This is important work. Come on. The people out there want to see. Yes, so you can go to our website, syzygy.fm, and find all the past episodes, all the show notes, all the pretty pictures that we put up along the way. If there's something that you would like to do for us, here's what you could do. It would be really, really awesome. You could spread the word. Tell anyone you can think of who's got a bit of an astronomical and cosmic bent to go and check out the podcast. You could give us a review on Apple Podcasts or Google Podcasts or Spotify or wherever you get your podcasts from. It doesn't really matter. Just go and leave a few words and a few stars to help us rise up through the noise of the podcast universe. That'd be really, really helpful. But otherwise, keep listening. We'll be back again in a week or so's time for some more astronomical goodness. So until then, Emily, catch you later. Stay safe, stay inside, hunker down, be good, get some exercise. I'll catch you in a week.
See you later.
Bye, everybody.
Bye.